Hey, what's up everybody? Welcome back to another 3D Thursday. You got myself, Noe Ruiz here. I'm a designer at Adafruit.
What's up guys? I'm Pedro Ruiz. I am the creative tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
Oh yeah, this is the show where we come here every week to bring 3D printed projects and DIY electronics to share with you guys in hopes to inspire you to make very cool projects too.
That's right, we go over modeling techniques, slicing, tutorials, all the nitty-gritty things you need to learn about 3D printing.
All right, we got some segments. Let's check it out.
That's right. Every week we have an assortment of awesome segments. We start off with, what are you prototyping?
Okay, this is where we take a look at some behind the scenes. What are we working on? Prototyping. Then we'll jump into some 3D news.
That's right. Every week we scour the net for some interesting stories to bring to you.
Oh yeah. We'll have a weekly video. This week it's another project video, cosplay.
That's right. Every week we bring
props.
An awesome, cool project for your 3D printing needs.
Okay, and then we'll end the show off with the layer by layer segment. You'll take a look at some CAD and tell us how you built your very cool project.
Awesome show, and we always have a cool discount code for you guys.
Oh yeah, this week it's Syringe. You get 10% off for your goods. It expires tonight at 11:50 p.m., so it's only good for today. Doesn't work on Eagle CAD or gift certificates, so get yourself some hardware.
That's right.
All right, let's go ahead and take a look at our lovely overhead camera.
So we can start off with what we're prototyping this week. All right, this week we are prototyping some new material from ColorFab.
Oh my God, this is the week of materials. This is some new material. This is bamboo fill from the guys at ColorFab. So this is a very, very cool project. This is the DIY soundboard project that we put together. It's coming out in the coming weeks, but this is really cool. Now we've played with a bunch of different types of wood composite filaments before, and this is by far one of the coolest ones. With the older filaments, we would get a little bit of a cardboard feel. It would be very bendy, and it would take a little bit, maybe a day to fully cure and harden, but this stuff hardens right away out of the bed. Super, super easy to print with. There's a bit of retraction error problems, but it is super easy to clean up. I really like this. It got me excited to like make more projects with wood bamboo fill in this case. Very, very cool stuff. I really like the look of it. You can change the color. And Pedro, you've been experimenting with different finishes, surfaces, and stuff. So tell me, what do you want to do with this stuff?
Yeah, so this is definitely really useful for doing finishing, like like what's called the veneer of like a project, and it acts just like wood. You're able to actually stain this guy.
Oh,
so
right.
we just use some darker stain to see what that would look like. What I really want to do though is try to get the clear coat stuff so we can really bring out like the little dark bandings that we're getting on this here. Really makes it look like bamboo.
Mm-hmm.
The way that you're able actually to achieve this is changing the temperature on your printer.
And another cool point that I wanted to bring up is the tolerances. The tolerances seem to pretty much be like PLA. A lot of the other different types of filament, like copper and bronze, you'll tend to get some expansion or even some shrinkage. This is a lot like PLA. There's no warping, minor shrinkage, and the tolerances work out just fine. So all the little standoffs and screw mounting holes worked just fine. I didn't have to tweak anything, which I really liked. So that's why I really like this filament. We're definitely recommending it for the Adafruit shop. Bamboo fill, it's from ColorFab. Very cool stuff.
Very cool way to get into woodworking when you're doing 3D printing.
Yeah, that's very cool. So last week you were working on some cool drone stuff, and this week you finally built a very cool prop guard system for your drone. Tell us about this.
Yeah, so we wanted to incorporate some landing gears, which it turns out we didn't really need. We wanted to launch this in our backyard. We have tall grass, so it turns out we can just toss these in the air. So I'm gonna have to update that. But what we did figure out was, or we had a chance to try out the carbon fiber PLA filament from Protopasta. So right away I printed these out and wanted to see the weight difference between this and a regular PLA part. So it turns out that we're saving 2 grams of weight with this. So as you guys know who fly drones, what is it, the weight for?
Oh yeah, the weight definitely is a big factor. 1 gram takes about a half a minute away from your battery time, so you're saving some minutes here.
Yeah, and you could definitely see the difference when you put these like on a scale. You can just see how much more or how much less these guys weigh. So all 4 of these put together I think weigh 4 grams. Oh, no, 6 grams. And when you compare it to the carbon fiber, it only weighs 4 grams.
It's awesome.
So you're saving 2 grams there.
So when you update your design, you'll probably even save more on weight. So that's really, really cool. I really like the design of these props. I haven't seen something like this where it kind of looks like wings or something, like it's ready for battle. It's really cool. I like the design. This is going to be a future project. You're going to make a nice learning guide and probably release the design file so you guys can modify it and take a look at it.
Yeah, check out our Instagram page. I think we have some footage up there of it trying to run into like a wall. You can see
it works pretty well.
It's pretty good, yeah. Okay. So awesome new material that we are still playing with.
Really cool, we'll figure out strength tests a little bit down the road as well.
It is a material-themed episode. We have now brass fill as well to play with. So we've been doing some tests on this, and right away the key points for this material is that it is lighter than the bronze or the copper fill. Yeah. It's definitely softer, a little bit more harder to work with in terms of removing from the plate because of how soft it is. You're able to bend it really easy. In terms of the shade of the color that you get more of a greenish type tint compared to the bronze. You get more of a darker fill there, or darker, sort of contrasting colors with that. You get more of a green tint, and with the copper, you get more of a yellowy type shiny.
I like the red in there too.
Yeah, you get like some sort of rose gold in there. So the copper and bronze, definitely heavy. Brass, way lighter than the other two.
Yeah, if you want it to look metal, but maybe you want it to, a drone fly or something, check out this stuff. If weight is an issue, there you go.
And just wanted to show how soft the brass material actually is. This is one of the prop guards that we were trying to remove from the bed. As you can see, it is pretty flexible there in terms of how soft the material is. So should have some, it's a little bit more fragile. Definitely wouldn't be able to use these, I don't think, in a cosplay prop like the copper that we did for this week's Syringe. So still experimenting on this guy. We'll let you guys know any updates on use cases. So far it seems to be for like statues, jewelry. So soft material, more of a greenish tint.
Now let's talk about our rotary tumbler, maybe the medium, and also we did a polishing video not too long ago about using the rotary tumbler in different mediums. So do you want to tell us real quick what do you recommend as a medium, what type of material?
Yeah, so we're using the same tumbler. The medium that we're using for the brass is, of course, brass screws.
So brass on brass seems to work pretty well.
And that worked really good with the copper as well, too. If you check back that video, that's what we used to get the polish for this copper. For bronze, since we want it to have the more darker feel, we are actually using stainless steel screws for this. So that's what will bring out more of the darker tones. We have tried using brass on this, and it just made it look exactly like copper. So definitely want to use
the right
steel.
medium to keep the finishing. Okay, and these are all used the same polishing techniques, but all different mediums. And that's one thing you want to look out for when you're polishing this stuff. Now, how long did I think I put it in for 4 hours or so? So each part is about 4 hours in the tumbler, which is actually a lot more better than hand polishing it that you'll see soon in the video that we have. So, okay.
More prototypes here. Are working on a very little tiny miniature.
That's right, folks. This is a sneak peek. This is a new Pi TFT screen for the Raspberry Pi. This is designed by Lamar in K-Town. It's actually so new. It's still purple. It's still from Osh Park. And the real cool thing about this one, do you want to show that off, Pedro? I don't want to get on your space there. This one's a really cool one. It has 5 buttons. It is a 2.4-inch TFT for the Pi. And what we're going to do with this project, we're going to make an update to our Game Girl project. This is going to be a pocket Game Girl using the Raspberry Pi 8 Plus, the smaller screen. Very, very cool project. Remember, we put together a Bluetooth gamepad not too long ago. So we're going to do sort of the same thing using a Permaproto, but of course we're going to have to saw it in a smaller piece there so we can fit everything in there. But it'll be hand size. It'll fit in your hand. Super cute. Very adorables. Can't wait to finish this one. It's in the works now, folks. So just wanted to show you guys like the little mounting area here. This is it's just for standoffs that are mounted like that. And then we also have the little test bracket here. So if you saw the video last week on standoffs, same approach. We just kind of cut this out. I didn't need to print all that because I'm just testing this. Very cool little project. Looking forward to it. Again, that's a new product that's coming out in the coming weeks. It's a 2.4-inch Pi TFT. So that is it. That is the prototype stuff. Actually, we're not done yet. We have more stuff.
Oh, yeah.
We have new filaments in the shop. You guys wanted some NinjaFlex colors, and now we got some NinjaFlex colors. I asked you guys on Instagram what colors would you like, and you guys spoken. Here are some new NinjaFlex filaments. You guys wanted some colors. We got colors. I asked you guys on Instagram what colors should we get, and these are the ones that we got in the shop now.
That's right. So we got the green grass, which is sort of like a neon type of color.
Yeah, very nice and bright.
We have the semi-transparent NinjaFlex.
Is it water or is it rain?
I think it's water, actually. Okay. So this is what we use to make the transparent nipple on the top part of the
this week's project.
Yeah.
The little sister
definitely
syringe.
Take a look at that later. We then got the lava orange.
Very, very bright, vivid orange. Love that stuff.
And then we have a very metallic, glittery gold.
Yep, gotta get the gold bling bling, like my hat here. Very, very cool filament. They all work you know, with extruders that work well with NinjaFlex. Very, very cool colors. In the shop now, if you want to get some, you can get 10% discount using our coupon code Syringe. So be sure to get on that and get yourself some new NinjaFlex colors. Okay. That's going to be it for the prototyping segment. Very cool. I think we're going to jump into some news now. Let's take a look at some news. Actually, first piece of news, it's kind of like a prototype segment. We have an update from Astra Prints. Yeah, so Daniel, the CTO from Astra Print, emailed me and said, hey, we got a beta that we want you to check out for the MakerBots in Sailfish. So now Astra Print's going to work natively with machines that use Sailfish firmware and native MakerBot replicators. So this is a big deal for us, especially since we still use our Replicator 2 quite heavily. It is a workhorse machine, works really well, very reliable, and now we can control it with our phone. When the MakerBot 5th gens came out, we were a little jealous because you can access it through your phone, you can get it on the Wi-Fi, you can get a camera, you can do all that now with DIY. You can get yourself a Raspberry Pi, plug it in, and you're up and running on your Wi-Fi network. So here I am heating it up, testing it out, kicking off a print.
It's able to generate X3G files, and then we can just wirelessly send these over to the printer without having to tether. We're using like a Mac Mini right next to the replicator because our SD card broke.
That's right.
So it's another reason to upgrade, you know, to an Astro Pi or an Octoprint.
Very, very cool. I love it.
Definitely a worthwhile upgrade for this.
Yeah, it's coming soon, guys. It's still in beta. There's very little bugs, almost no bugs. So that's really, really cool. Yeah. So we'll keep testing it, and we'll let you guys know when it's ready. Okay. Next up, you just saw it, Mr. James Bruton peeping in, saying what's up. This is a very cool project. Every week, James has got a new update to his massive project. This week, HulkBuster. This is really cool. As more content comes out from the Avengers trailer and movie, James is revising his thing bit by bit. This time, massive arms. This thing is a multi-part print using NinjaFlex for the flexible joints in the fingers, and then rigid ABS material that's acetoned, chemically bonded together to make these massive parts. Very, very cool. In this update, he goes through his CAD, walks us through some of the mechanisms for the arm, prints it out, and now he's starting to look at a bunch of options for mounting.
Servos.
Yeah, so servos, electronics. This is really cool. Here it is with the arms all built in there. Very, very nice looking. He's even using nylon filament as the string cords to make the hand open and close. Very, very cool approach there. Here he is testing that mechanism out. So when you tug on those wires, you get a nice sort of, you can open up your hand like that for shooting out some laser beams, and then you can close the fist like that so you can shoot out some rockets. Very, very cool.
Yeah, there's a lot of components that he's working on for this. Yeah. And what's the really cool part is now he's jumping into Arduino and showing off how he's going to be coding a lot of the logic for the servos and the LEDs coming out. Yeah. So here he is drawing some schematics of how everything works. Really love his explanation of how he's actually coding this as well. He jumps into Arduino IDE and he's looking at some of the definition declarations that he's added to his file. He's going to be releasing these for free. And you can check out a very nice explanation of how everything's being triggered, how everything works.
And then on the finale, he gets a nice little prototype mocked up here. Let's see if I can get to that part. So basically, hit a switch, it activates a servo, and then fires off his LED. This is a really cool circuit because you can use this for all sorts of different projects. So you'll be seeing more of this from James in the coming weeks. Very, very cool. Gotta watch out for it, and hopefully next week we'll see some more stuff on the Unibeam, that part that you put together. A couple months ago we collaborated and put together a Unibeam for the center chest, which is a very, very cool project in collaboration with Phil B. Very cool. So be sure to check out James's YouTube channel and his projects.
Yeah, can't wait to see some of the code that he's going to use to run all of the NeoPixels.
That's right.
So definitely keep a lookout for that, and you can watch the previous episode where we built the Unibeam. You can download all the STLs, get all of the parts on learn.adafruit.com. Definitely don't forget to subscribe to James Bruton's channel for weekly updates on very awesome 3D printable wearable projects.
Huge, huge, massive projects. Okay, next up, continuing with the material. This is like Materials Week. Type A Machines came out with a new spot on their website dedicated to materials. This is really cool. We really wish more printer manufacturers did this, but Type A Machines went all out, made a dedicated page, and has all different types of materials listed out.
That's right. There's like over 20 different types of materials with the Cura profile, so you can get and use these right away.
Yeah, that's right. That's the big thing too, is to have different slice settings, different temperatures, all of these different materials take different types of temperatures, what they're good for.
They did all the testing with all these materials to make sure that they all printed, optimal quality with all the settings that they chose.
They make sure it works. So let's start off with a couple things, maybe something that caught your eye. This is some new stuff. This is like polystyrene, I believe.
Yeah, the IGUS I-180. I've never heard of this stuff when they were sending over some of the profiles before, but very interesting if you read some of the details on there. Yeah. So when we create snap together parts, we've noticed that after 20 snaps or something like that, you start losing tolerance because you start snapping off little bits of the material, which will make it less loose, and over time won't even snap back on.
You get a bit of friction on all these type of tolerances. So this is a really cool one that that has sort of a lower rate of wear, which is something I hardly see in materials. So that's really cool. So specifically bearings, motion components, sliders, test rigs. This is what this material is for. It's really cool. So if you have something that needs to withstand a lot of tight tolerances for a while, this is some cool material to take a look at. And I think they have some other material too that's similar, but a little bit more, it weighs less. So maybe if you wanted to make a prop guard or something. Sorry, I'm clicking on the wrong thing. I have to click on that one. Yeah, so this is basically the same stuff, but just a little bit lighter than the same type of rate wear, which is really nice to see. Very cool. And there's also little notes and stuff like that. 280C, that's a really high temperature. You don't want to go that high because it can release some different fumes and such, or it can even damage your nozzle. But they've done all the testing for you, so that's really cool. Here's a look at carbon fiber PLA from Protopasta. This is what you used on your prop guards. And they even have a little arm here showing it's for probably a drone. So this is for lightweight stuff, things that are pretty strong.
And I like all the cool little notes here. This one does cause a little bit of accelerated nozzle wear. Okay. So just keep a lookout for some of those.
Yeah, and they all have the data sheets, the technical data sheets here. And of course, like you were saying, the Cura profiles is very, very cool.
Yeah, and even if you're not using Cura, you can just take a look at the, what is it, the ION file.
Oh, that's right, yeah.
And check out some of just open it up in a text file to see what settings they're using for that.
Temperatures and stuff.
Other interesting ones are iron PLA, which has magnetic properties. You can definitely use these for sensors, for, like the Z probe or something like that.
Sure. Compasses, sensor components. And the shielding, that's an interesting one. So if you wanted to shield your components from like certain frequencies, this is a good material to do that. Very cool. And this is also from Protopasta. They're making a lot of cool different materials. I think there was another one that was really interesting. Stainless steel.
This is definitely one I'd like to try out.
Very cool.
Has a very nice finish. You can use it in a tumbler. You can use a wire brush or even a polishing wheel to get the shine out. This would have been very cool for the gun blade. The little pendant, the little dragon pendant would have been excellent. And I think I even would have taken a shot at doing the chain links to connect all that together.
That'd be interesting.
So yeah, definitely going to be really cool for jewelry, awards, figurines,
Another
crafty.
type of abrasive material, so you want to be careful when using this stuff, but very cool. Let's take a look at some other stuff. Conductive PLA, for you folks that want to make conductive game pads or capacitive touch pads. This stuff from Protopasta. Very, very cool. Simple electrical stuff.
Yeah, definitely going to need a dual extruder for this, or you can just print on top using the change filament command.
Or just manually do it.
Yeah, so
Very
still
cool.
some cool tests yet to be done with that. And of course, they run through some of the you know, copper, bronze. They have the wood filament in there. You can check out the full list. Another interesting one that.
Do you want to go back there?
Yeah, the
XT stuff?
Yeah, the XTC copolymer stuff is pretty cool. It's
XT, yeah.
XTC.
Oh,
or
XT
XT copolymer. Sorry.
Yeah,
So yeah, it's FDA approved. So it's improved for food contact items. Definitely don't recommend.
Yeah, we don't recommend that. Like
just because of the way the
utensils.
layers are, you know, food can get stuck inside there. So pretty cool for prototyping.
Yeah, it seems to be pretty strong since they have quite a bit of different specs for PSI, so sort of water pressure. Like how does it last with the pipe or something? This is pretty interesting.
Yeah, so a lot of some of these are going to need a heated bed.
Oh yeah,
Little Birdie told us that they are working on a heated bed. So
Type A machines.
Type A machines.
They're working on a heated bed.
So they have they have the structures actually put a hood on top. You can put plexiglass on the side. So their machine's already built to you know, withstand that.
That's awesome.
So definitely a cool upgrade to look out for.
Okay. And speaking of really, really strong stuff, the next page, I have 2 pages here. This is all nylon stuff. So the stuff from Tallman and some other places, this is all broken out. There's so many different types. We tested some TPE stuff, and there's even some other stuff that I've never heard of. PLA Tanium,
Yeah,
Titan, I've heard of that one.
Definitely check out the
T-Glaze.
blog to check all these out on your own. Download the profiles and start experimenting with different types of filaments.
Yeah, very, very cool. Even if you don't have a Type A machine, this is still going to help you out. And if you're using different materials, find the one that's best for your project. Since this is a material-driven week, this is a very good story. So very cool stuff from Type A machines. Definitely check it out. Okay. All right, so this week it is Little Sister Syringe. So we're just going to take a break, let you guys see the video, and when we come back, we'll have a very cool layer-by-layer segment.
Yeah, let's check it out.
All right, we'll be back.
Coming up, we're making a prop from one of our favorite video games.
That's right, this week we're making Little Sister Syringe from BioShock.
To build this project, you're gonna need some supplies, some handy tools, but we got all the stuff to build this project in the Adafruit shop.
That's right, the design files are free to download and you can follow the full tutorial on the Adafruit Learning System. Link is in the description below.
This thing is creepy cool. 3D printed in copper filament for the body, and we're using transparent PLA for the bottle, and rubber Ninja Flex for the topper.
That's right, it has a trigger that actuates a push button and turns on the LED, making the bottle glow bright red.
We 3D printed this massive needle, which is a whopping 400 millimeters long. Let's go ahead and take a look at how we started on the design.
We'll start off by searching for reference material and then trace out the paths to make the artwork. We'll then import the paths inside of Maya and then shell out the design parts inside of 123D Design.
To 3D print the parts, we're using the Type A machines Series 1. We're using copper filament to give the parts more weight, and it's also going to give it a really nice grungy and steampunk look when we polish these parts.
You can check out the review on copper fill in this video here for more information on polishing techniques.
Each part takes about 2.5 hours to print.
We found that the best way to remove copper filled parts without damaging the blue tape is to use a palette knife and a spatula.
Most parts that are printed in copper fill are going to need some cleanup, so we can trim off the stringy bits using our fingers. We'll move on to the haku snips and then the palette knife.
The standoffs are printed with a tight tolerance, so we're going to need to tap the screws using a couple of tweezers.
We designed the standoffs to fit number 256 screws, so you'll want to fasten the screws into the standoffs to create the threading.
Okay, now let's go ahead and take a look at some of the polishing techniques. We tried out the Dremel polishing kit and found these 3 bits work the best. The white detail abrasive brush, the 280 and the 320 grit abrasive buff.
Now polishing takes a lot of time, so you're going to need at least an hour for each side to get that shiny finish. You're going to want to focus on one section at a time, try to blend the layers together, and go back over sections to even out the surface.
You can then switch to the white abrasive brush for contours and hard to reach areas. Use the slowest speed to polish the surface without damaging the base layer.
Next up, we'll apply some polishing compound to the surface using gloves, and we'll rub it into the holes to fill in the surface.
The 320 grit abrasive buff helps smooth out the finish and adds contrasting tones to the overall look of the parts.
Comparing the surfaces of these parts, you can really see how well the polished part came out. It's definitely worth the time finishing your copper-filled prints, and it's a great alternative to the rotary tumbler.
To make the circuit, we'll start off by measuring 3 wires. We're going to be using the 30 gauge silicone-coated stranded wires for this.
We're also going to use copper foil tape, which we're going to use to connect the rechargeable coin cell battery. We'll cut 2 pieces and add a blob of solder so we can connect to the silicone-coated wires.
The 10mm LED is connected to a 6mm tactile button. We're going to need to tin and connect it to the rest of the circuit. You can read the full guide on the Adafruit Learning System.
Next up, we'll solder the positive and negative connections on the LED and seal it with heat shrink tubing.
The copper tape has an adhesive back, so we're going to need to peel back a small portion of it to stick it to the positive and negative sides of the coin cell battery. Leave some of the backing on so the copper tape doesn't touch the side of the battery.
The bottle was printed in translucent red PLA, which diffuses the LED really nicely. It was also printed without any supports at 200 microns.
We found if you orient the needle on the bed diagonally, we can print it as large as it can, which turns out to be 434mm long.
We printed it in 2 halves and just glued them together using E6000.
Since clamps won't work, you're going to need to hold them together for about 5 minutes until the 2 parts stick together.
The LED itself is inserted into the base of the bottle and it's just mounted in place. Both the bottle and the needle are clamped in place when the 2 parts are joined together.
Before securing it shut, we'll check to make sure that the tactile buttons are mounted in place. Test the alignment of the actuator to see if it lights up. The rubber Ninja Flex topper grips nicely onto the bottle and diffuses the LED when printed in transparent Ninja Flex.
And there you have it, little sister Syringe. Definitely one of the coolest 3D printed props that uses multiple materials and of course some simple electronics.
Polishing techniques will definitely come in handy in future copper-filled projects.
So let's take a look at what we learned.
So recessed standoffs increase in tolerance with Z depth.
Diagonally orienting thin parts will increase the bed volume by 100mm.
Then we also learned about Dremel polishing tips and polishing compounds.
So if you're thinking about 3D printing your next cosplay prop, definitely check out this stuff from ColorFab and Fender Drives. We got both of those in the Adafruit shop.
Definitely let us know what you want us to build in the comments below, and be sure to hit that like button if you want to see more cosplay props.
And if you want to see us talk about more CAD and slicer settings, tune into our weekly 3D printing show every Thursday right here on the Adafruit YouTube channel.
So that's all for this week. Thanks so much for watching, and don't forget to subscribe for more 3D printer projects from Adafruit.
See you guys next time.
All right, and we're back. This is the syringe that you saw in the video. It's the exact same one actually that we used for recording. So very big prop, has a nice weight to it. You can definitely swing this around without too much effort. I really love the big size of all of this. The eerie red glow really brings the whole project together.
Oh, yeah, that's the best part of the project, yeah.
Yeah, the only thing
materials and DIY electronics.
Yeah, the only thing that's missing is probably having like some copper little buttons to hide the machine screws or something like that.
It adds to it.
Yeah, but if you want to switch over to the overhead, you can see some of the detail.
I have the layer by layer queued up. Do you want to just jump into that?
Oh yeah, let's go ahead and just jump into how we actually built this.
All right, so here we are.
All right, so as all projects, we start off with some reference material that we just Google. For this, I imported inside of Maya, simply because we're able to trace on top of photos. So I did a quick mock-up of just extruding how the basic shape is going to look like. You can see more in the guide on learn.adafruit.com on how I built this.
Cool.
So the thing that isn't really good in Maya, though, is being able to assemble all the parts. So for that, I brought the STL inside of 123D and simply just recreated it again. I know it may seem like it's,
backtrack a little bit?
A little bit of backtracking, but I wasn't able to, trace completely the photo that we have. So after that, we went ahead and grabbed some of our widgets that we've worked on before, specifically the rechargeable coin cell battery, which you can find on our 123D gallery page. Okay. And all this is just the little cylinder there that's completely fitted, so we can just snap on and have a nice tolerance of holding the coin cell. We also grabbed the tactile button that we used as the momentary push button in there. And for the handle, I actually imported the vector file because I wanted to be able to apply fillets and smooth it out and change the trigger guard according to my hand. Okay. So the quick tip here is that you don't want to scale your SVGs because the SVG phaser that's inside of 123D can get a little wonky. So you want to extrude your SVG file and then scale up the model that you extrude out of that, and you should be able to scale it with no problems there.
Okay.
After that, I was able to go in there and start to shell out the both bodies. And here you can just take a look at some of the way that I created the standoffs. For more on that, you can check out the last week's video that explains how Noe creates a lot of his standoffs. Okay, so the tip here is not to merge anything that doesn't need to be hollowed out first. So 123D can freak out a little bit if it tries to hollow out areas that are too small, So the trigger and the trigger guard don't need to be hollowed out. So what you want to do is wait or keep those separate until you hollow out all of the geometry that you're going to need to before you merge all those together.
Okay.
Next, we are looking at just forgot to mention the way that we created the sort of curved geometry there. It's just a bunch of ellipses that we select and then loft all together.
Cool.
Okay, so the second tip that we ran into was in the standoff, the radius for it. It actually increases as the curvature of the cylinder goes up. So you definitely want to look out for that. I think it's like by 0.4, 0.8 difference that you want to increase that to make the screws fit inside of the standoffs.
Okay.
The next tip for standoffs is because of the cylinder, they have to be a little bit further away from the wall. And if you were to print those out, the cylinders for the standoffs would just pop right off.
That's right.
So you want to add a little bit of strength to that by adding a little bit of geometry that connects the standoff to the rest of the body and to the wall of the entire, the shelled out, sort of cavity of that.
Okay.
So that's another thing that you want to do with standoffs that are inside of cylinders.
Very cool.
Okay, another thing you want to do if you're not printing in copper fill, you can definitely just print this in regular PLA and do a paint job on that, is update the tolerances that hold the bottle together. So all you want to do is go into the walls there and just push that in a little bit by like 2 or by 4. And you're also going to want to do this to the wall that holds the needle in place. So yeah, you can definitely use regular PLA if you don't want to use the copper fill. It'll make it a lot more, less weight, so you can definitely do that. You can check out the complete step-by-step, get all the STL files on learn.adafruit.com if you want to build your own. This is definitely a fun project to build for your next, cosplay event or even Halloween. Very simple dress-up for this one.
Very, very cool. I love this project. Definitely a great use of Ninja Flex. Transparent stuff, metal filament, and of course the Type A machine really helped out here because you can print very massive prints. But if you wanted to, you can take Pedro's file and chop it up even more and print it out in several pieces.
Yeah, you can make this needle a little bit smaller if you need. All of the curves are there, so all you got to do is just move this down a little bit and then just loft between it to make it smaller.
Sure.
You can definitely update that. And we didn't get a chance to talk about the water Ninja Flex that we're using on the nipple here. So we just did the change filament command. So we just printed 2 of these in one print. So we're using the Caramel Ninja Flex color, which closely resembles the the copper.
It's pretty close.
It's pretty close.
We tried so many. We tried like every color.
Yeah. So this was the closest that we could get.
Yeah, we even tried gold. Gold didn't seem to match too.
Yeah, it's a little bit of a green tint to it.
Yeah,
you can see there. But yep. Definitely pick this up. You can paint it if you wanted to as well.
Okay. Very, very cool project. Again, check out the Adafruit Learning System and let us know what you think. Yeah?
Yeah.
Okay. All right. I think that's going to be it in today's show. Again, we want to encourage you folks to pick up some DIY electronics for your next project or maybe some printing accessories.
That's right. Use the discount code Syringe during checkout. Save 10%. You get some 3D printed accessories and electronic parts for your next printing project.
That's right. Okay. We're going to leave you guys with some links so you can check out more projects.
As we said, all the step-by-step guides for all the projects that we do live on learn.adafruit.com. You can check out circuit diagrams, STL downloads, and step-by-step builds.
That's right. You can, if you have a project that you'd like to share with us, you can go on our show and tell. That's on Google Hangouts. check out plus.google.com/plus symbol Adafruit. The link is there, right? So if you want to share your projects off, you totally can. We love it when you guys do, and we're always there, so you can come and hang out with us.
That's right. Every Thursday is 3D Thursday, so check out all of the 3D printing stories that we have up on the blog. Just search for 3D Thursday.
That's right. And you can follow myself at Ekin and Pedro at VideoPixel and Adafruit at Adafruit on Twitter, Instagram for behind-the-scenes stuff. Very cool stuff there.
Always posting cool new behind the scenes there. Check it out.
Okie dokie, folks. That's it for this week. Thank you guys so much for watching. We'll be here next week where we have some more cool projects and more cool stories to share.
See you guys.
All right. Bye, everybody.